Okay, this is question 2 from 2008, the AB AP Calculus exam. So again, this is part of the calculator active section. So you would have your calculator for the first 30 minutes, and that would include questions 1 and 2. So this question says, concert tickets went on sale at noon where t equals 0, and were sold out within 9 hours. And the number of people waiting in line to purchase tickets at time t is modeled by the twice differentiable function. So right away I'm seeing twice differentiable. That lets me know that this is continuous because differentiability implies continuity. So I'm kind of keeping that in the back of my mind. Function L for, and I have my times here of 0 and 9. And the values of L are shown on the table above. Okay, so basically I have people and hours there. Immediately what I notice about this table is that the changes between the hours are not consistent. What I mean by that is from here to here is 1, but from there to there is 2. So I kind of make that note that my intervals are not equal. And now I'm going to kind of look and see what they want me to do here. It says use the data in the table to estimate the rate at which the number of people waiting in line was changing at 5:30, which is 5.5. Show the computations that lead to your answer. Indicate units of measure. Guys, if they say indicate units of measure, that is part of, it's usually on the scoring guide that you need to have those units to get full credit. So make sure if they're asking you for those units of measure that you definitely indicate them. All right, so basically what I'm trying to figure out is the rate of change at 5.5. Well, 5.5 is not on here anywhere, but 5.5 is between these two things. And since I'm just estimating the rate of change, that means I'm going to find the slope. So I can, given 2 points, I can find the slope. This could be an Algebra 1 problem right here. So for part A, rate of change equals slope of change equals slope. And I'm also just going to make a note that 5.5, right, is between 4 and 7. So I'm going to use this point and this point from the table. All right, so let's see. Remember your slope formula, y2 minus y1. So y2 minus y1. So that means I'm going to have 150. So my slope equals 150 minus 126 over 7 minus 4. And again, this is a calculator section, so if you need to use your calculator for that, you can. But when you subtract that, you get 24 over 3, and that comes out to be 8. And if you just left your answer as 8, you would not get full credit. Because it asks for units of measure, you need to say, what is that 8? Well, let's see, it's going to be people per hour. So it's 8 people per hour. So make sure you indicate units of measure, especially if they ask for it. All right, so we got a couple points there. I think that was worth 2 points. So let's see if we can now get some more points from part B. Part B says use a trapezoidal sum with 3 subintervals to estimate the average number of people waiting in line during the first 4 hours that tickets were on sale. Okay, this is kind of a tricky one because so many of the examples that we look at say 3 equal subintervals. This does not say 3 equal subintervals. So that normal formula that we use, the delta x over 2, parentheses, and then you double all those, that's not going to work for this problem because they are not equal subintervals. So you kind of have to go back and recall the formula for a trapezoid. So what I did here is I kind of have a little side picture here. So recall this. Your area of a trapezoid is 1/2 base 1 plus base 2 times the height. Now, when we normally think of this trapezoid, if this is the trapezoid, right, your base 1 and your base 2 are here. So you add those together, and then you multiply by the height, and then the whole thing divide by 2 or multiply by 1/2. The problem is in these problems, remember, we're doing the trapezoidal sum. So think of these trapezoids, the interval from 1 to 2, 1 to 3, and then 3 to 4, because it did say we were only going to 4 hours. Remember, your trapezoids look like this. So your bases are these right here. So it's almost like they're the heights, right? So just kind of, however you do that formula, just keep in mind that this is your base 1, this is your base 2, over your height, over there. Okay? So kind of keeping that in mind, now I'm going to set that off to the side. and I'm going to, like I am going to mark that down. So subintervals are not equal. Subintervals not equal. Therefore, can't use that formula. And that formula is that one, you know, the delta x over 2, that parenthesis. Can't use the formula that we normally use. Can't use the formula, right? Okay. So for this trapezoidal sum, what we're going to have to do is we're still going to have the area of the trapezoids. We're going to have to actually add those up. Now, it's not going to be too bad because we only have, you know, 3 of them to do. So the area for the trapezoid, okay, so area of this trapezoid, I'm still going to have that 1/2 out front, but now what I need to do is I need to figure out the, like for each one of those subintervals, right? For each one of these subintervals, I need to do base 1 plus base 2 times the height for those. Okay? So that's what I'll do next. Okay, so I'm going to have that 1/2 from this formula. Now, again, this is the formula you're kind of thinking of, but remember, the height of this triangle is going to be each subinterval. So from 0 to 1, that height will be 1, right? Because think of it this way, because that's the height of this trapezoid right here. And then the base 1 plus base 2, well, that's what I'm going to have to use these numbers for. So I'm actually going to have to put those together. So it'll be 1/2, okay? And then I'm going to have 120 plus that 156, okay? And then that's going to be multiplied by the height. Well, the height from 0 to 1 is just a 1. So we've got that. I guess I could have written that a little lower, sorry. And then plus, all right, well, what else do I have? The next one, the height of this, right, is going to be 2. So it'll be 2. And then base 1 plus base 2. Well, it's going to be this plus this. So that's 156 plus 176. Okay, plus the third one, again, this is the height of the third one. You almost have to think of it like this, okay? So that height from 3 to 4 is just 1, and then base 1 plus base 2, I'm going to get those from here. So that's 176 plus 126. And again, it's not that these calculations are that difficult, but you do have a calculator, so you can use that as needed. So I end up with something to the effect of 1/2. When you do that on your calculator, I got, what did I get? I got 621 altogether, okay? And, oh, that was after I divided it by 2 already. Whoops, sorry. So, let me just... So I got 1/2, and then this number was 276 plus 664 plus 302, okay? And so after you add all those together, then divide by 2, that gave me a total of 621. Now, what's really tricky here is that that 621 actually isn't your answer. If you think about what we just solved for, okay, what we solved for was the total people over 4 hours. So go back to the question. Did you answer the question asked? The question says to estimate the average number of people. This is the total people over 4 hours. So my suggestion would be, every time you see in a problem, if it says the average number of people, figure out the total, and then, well, how do you find the average? So the average over the 4 hours was 621 divided by 4 hours, so the average per hour. And again, you could do this right on your calculator. So you have 621 divided by 4, and so you get that 155.25. And that is your final answer for this one, okay? So we've got that. All right, so again, to find that average, we just need to make sure that we divide it by 4, so we've got that. And that would get you the full credit for Part B. All right, moving on to Part C, okay? So for Part C says for 0 to 9, what is the fewest number of times at which the derivative must equal 0? Give a reason for your answer. Okay, the way I would have tackled this one, okay, what makes sense to me is I know that the derivative equals 0 at the critical values. So that's what I would write down. I'd say that the derivative equals 0 at critical values, okay? So to me, that's basically asking me to find some critical values, and I think of this as a sign chart. Now, I would do a sign chart to help me reason through this problem. Remember, a sign chart is not justification. AP Central will not count a sign chart as justification. So if you're going to use a sign chart, you need to kind of summarize what your sign chart means. Oops, sorry. In there. So for me, though, to make sense of this problem, I'm saying, all right, the derivative compared to the original. Well, what do I know? I know that if the original is increasing or decreasing, right, that tells me information about the derivative. I could tell if it was positive or negative. And if you change from increasing to decreasing, you have a relative max or relative min. That is a critical value. So I went back up to the top, and I kind of can't fit them both. But what I did is I said, okay, over the intervals, I'm looking at all these values, okay? I put all those on my sign chart, and then I'm looking at this value, and I'm saying, am I increasing or decreasing from 120 to 156? Am I increasing from 156 to 176? Yes. So I'm going to go down here, and well, let's see, I've got 0. And I gotta put, what else do I gotta put on there? 1, and a 3, 4, 7, 8, and 9. Oh, sorry, I should have made that sign chart a little bit bigger, but oh well. Okay, so, and again, what is it doing between 0 and 1? Well, it was increasing. I went from 120 to 156, so it was increasing. From 1 to 3, it went from 156 to 176. That's increasing again. But then it goes from 176 to 126, so it's decreasing. So if you go from increasing to decreasing, that means you have a critical value, okay? And so you're just going to fill in the rest of this chart. Between 4 and 7, you're increasing. Between 7 and 8, you're decreasing. And then you're decreasing again, okay? So this is kind of this was like my own sign chart. So I know that critical values, so the derivative equals 0 at critical values, and then I'm just going to make a note here that critical values occur when f of x, or here f of t, sorry, f of t goes from increasing to decreasing, or vice versa, right? Vice versa. And you are allowed to use that terminology on the test. So basically, let's see, increasing to increasing, so 1 is not a critical value. But from 1 to 3, you go from increasing to decreasing. So t equals 3. And then you go from decreasing to increasing. T equals 4. That's a critical value. And looks like when you go here from increasing to decreasing at 7. At t equals 7. Okay. So those are critical values. Critical values. Okay. And make sure I'm answering the question. Let's see. Based on the model, how many... Oh, sorry. This is C. What is the fewest number of times where the derivative must equal 0? Well, the fewest number of times, I've got 1, 2, 3 places. So my answer is 3. So 3 places where the derivative equals 0. Okay, and that's my answer for that one. Okay, so for part D it says the rate at which the tickets were sold is modeled by this R equation that was given. Okay, based on the model, how many tickets were sold by 3 p.m.? Okay, so I'm trying to figure out the total. I need to integrate from 0 to 3. Okay, so that's going to equal the integration from 0 to 3 because I wanted it till 3 p.m. And we're just integrating that R of t dt, and that's going to be a straight calculator question. So all you need to do is make sure you type that in correctly. So for here, again, you get that under Math 9. So you just do Math 9, and you type that in, hit Enter, and it gives you 972.784. And so then you just need to round that. So once you round that, you get a total of 973 tickets. And you're done, and you got full credit for this one.